All right, in this video, we're going to begin section 6.3, which is about multiplying polynomials. Mostly, we're going to be focusing on multiplying two binomials together. So if you remember what a binomial is, that should have conjured up an image of what we'll eventually be doing. So let's do a couple warm-up questions just to remind us what we'll be dealing with today. So multiply the polynomials together. This is a monomial times a larger polynomial, so also known as the distributive property. So x times 2x cubed, hopefully we're all good here, 2x to the fourth minus 5, x times x is x squared, and x times 1 is simply going to be x. Next one, oops, spotting that negative, going to pay attention to it the whole time. A negative times a positive is a negative. 3 times 4 is 12. X squared, x cubed, x to the fifth. A negative times a negative is a positive. 3 times 5 is 15. X squared and x squared is x to the fourth. Negative and a positive is a negative. 3 times 3 is 9. I have no more x's to multiply, so I'm just going to keep it at x squared. And, this next one I made a little bit trickier. We're multiplying xy squared times those two terms. And so we're going to do nothing different. We just have to pay a little more attention. I have x times x squared, x cubed. Y squared times y would be y cubed. Minus x times x is x squared. Y squared, there are no more y's, so we'll just maintain the same number of y's. Nice and simple. Okay, now let's review what we did on the last lesson. Let's factor out a common factor. Check by multiplying your work. So in other words, we'll distribute when we're done to see if it's right. All right, so looking at this problem, I'm noticing, and I think this was very similar to one of the problems we did on our other lesson, I'm noticing a 6. 6 goes into all three of those, but 12 doesn't, so 6 and x would be my answer. So I can factor out a 6x, leaving me with a 2, an x squared, minus a 3 and an x, minus a 4 and no other additional x's. Let's check our work. 6 times 2 is 12, x cubed. 6 and negative 3 is negative 18, x squared. 6 and negative 4 is negative 24, and I have 1x. And there you go. So we checked it, and it's good. Oh, one last check. 2, 3, and 4. Is there anything more I could have factored out? And the answer is no. They have no other common factors. All right, 16x squared minus 8x minus 8. I hope it's obvious that the only thing I can factor out is an 8. 8 would have to be the biggest because 8 goes into all three of them, and 8's, you can't take more than 8 out of 8, so 8's the answer. And this would be a 2x squared. And when I factor an 8 out of 8x, obviously I just need the x. And then what do I have left when it's just minus 8? Some of you might want to just kind of cap it off right there and say that's the answer. But then when you check it, right, 8 times 2 is 16x squared, check. 8 times negative x is negative 8x, check. But now I have nothing left to multiply to get the negative 8. So we have to have a term for all of my terms. So we had 3 to start with. I need 3 here. So what do I need to multiply 8 by to get 8? In this case, it's a minus and a 1, of course. Now, 8 times negative 1, negative 8. So don't make that mistake. It is a pretty common mistake for kids who are kind of getting it, but still kind of making mistakes. That'll be the biggest mistake you'll make in a situation like that. All right, a 9x squared minus a 36. 9 times 4 is 36, and so 9 can factor out. So I'm going to factor out a 9, leaving me with x squared minus 4. And that would be my factored version. 9x squared, check. Negative 36, check. All right. So today, we're going to focus on multiplication, and we're going to do so with what's known as an area model. So what I have got here is two polynomials, 2x plus 8 times 2x plus 10. And we are going to model a rectangle designed around those two polynomials. So let me explain. If you look across the top here of this rectangle, and I asked you how far across it is, if I told you that the length from here to here was 2x, and the length from here to here was 8. So then how far is it all the way across? All the way across would simply be 2x plus 8. And if the distance from here to here is 2x and the distance from here all the way down is 10, then the total distance here would have to be 2x plus 10. So that is why that this rectangle I have drawn represents the multiplication. Well, let me talk about that in a second. Represents 2x plus 8 and 2x plus 10. Now, finding the area of a rectangle, you should have maintained that knowledge. An area of a rectangle is just the length times the width. And so our length is 2x plus 8, our width is 2x plus 10, or vice versa. But this is why we can represent this multiplication problem with this rectangle. Okay, and in this rectangle, we actually have 4 smaller rectangles. So one way to find the area of the whole thing would be to find the area of the 4 pieces and then add them up. So let's just call this like piece A, piece B, let's call this C, and this D. So then all we have to do is find the area of A, add the area of B, add the area of C, and add the area of D. So what is the area of A? Well, it's just a rectangle individually, so we're going to stick with our length times width for each rectangle. So the area of A is simply going to be 2x times 2x, or 4x squared. So let me write that in. I'll write that in a minute. The area of B is going to be, now what are the dimensions of B? Well, it's 8 across the top, and then it's still just 2x across the side. So plus 8 times 2x, or 16x. Area of C is now 10 units down the side and still just 2x across the side here. And so the area of C would be 10 times 2x, or 20x. And the area of D would be 8 across the side here, right? This is 8, and this is still 10. And so plus 8 times 10, or a total of 80. So what now is the total area? We would just add these all up, making sure to add any common terms together. So now I'm just adding this polynomial together, and I'm going to report it in standard form. There are no x squareds other than the 4x squared. But I do have 2 x terms. So I have 20 and 16, which makes 36x. And then I have my 80. So the total area is 4x squared plus 36x plus 80, telling us that 2x plus 8 and 2x plus 10 multiplied together is equal to 4x squared plus 36x plus 80. Because the area of the whole thing is simply length times width. And we know that the area is all those little pieces added together, which we have just found. And so we have our 4x squared piece. We've got our 16x piece. We've got our 20x piece. and we've got our 80. And if I add all four of those up, I get the answer, which is the area, but also the answer to the multiplication question. Okay. That is using an area model or a table model to multiply two binomials together. So let's go ahead and just practice that very quickly. I'm going to draw a rectangle. It does not matter the size. I'm going to label the top as x and 3, because x plus 3 would be x and 3. I'm just going to divide it up between the two. The relative size is irrelevant. We're just going to label and use it as a mental guide. And then this we'll label as x and 2. And now we'll find the area of each of the individual pieces. So x times x is x squared. 3 times x is 3x, because this is still x here, right? X times 2 is 2x, and 3 times 2 is 6. Therefore, the area is going to be x squared. I have a 3x and a 2x, which adds together to be 5x, and then I have a 6. So the answer to the multiplication question is x squared plus 5x plus 6. Okay, so try the next three on your own and then resume the video to see if you got it right. All right, making a rectangle. Again, I'm not worrying about the relative size. I'm just going to label and cut it up. 3x and 4. Don't care the size, cut it up. And now just do your math. 2 times 3 is 6. This is 6x squared. 1 times 3x is 3x. 8x, and 1 times 4 is 4. So my answer is 6x squared plus 11x plus 4. Now, this one has a negative in it. We are not going to worry about that, even though it might seem weird to like draw a link that's negative. We're just using the visual to help us organize our multiplication more so than anything else. What I mean by that is I'm still just going to call this 2x, and I'm just going to call this a negative 3. This is x, and this is 5. 2x times x is 2x squared. Negative 3 times x is negative 3x. Okay, see how I handled that? 2x times 5 is 10x, and negative 3 times 5 is negative 15. So it's important that when you have a subtraction, you treat it as a negative 3 and organize your multiplication in that way. So that gives us an answer to this multiplication question of 2x squared. We can combine these together, plus 7x minus 15. All right, this one a little bit different looking because I've got an x squared, but we're not going to change our plan. We're just going to label this as x squared. We're going to label that as a 1, label this as x, and this is a negative 3. So this is x cubed. X times 1 is x. Negative 3 times x squared is negative 3x squared. Negative 3 times 1 is negative 3. So I add them all together in standard form, and it looks like I don't have any common common terms. So I'm just going to write it in standard form. X cubed first, negative 3x squared second, plus x minus 3. This time we didn't get to simplify anything. All right, so next up is just doing some practice. I got various questions for you to do here. Let's zoom out so you can get a good look at all 4 of these. So go ahead and try those on your own. Make sure you get really good at this and check back in a minute. See if you got the same answers I did. X, negative 1, x and a 2, x squared, negative x, 2x, and a negative 2. X squared plus x, when I combine those, minus 2. Rectangle, 2x squared and 7, 6x and minus 5. 12x cubed, 42x, negative 10, should have made this bigger, x squared, and negative 35. I don't see anything in common, so I'm just going to write these in the right order. 12x cubed minus 10x squared plus 42x minus 35. That is the answer I get when I multiply. Learn my lesson on the last one, make it bigger. X squared negative y, x 2y cubed. X and x squared is x cubed. A negative xy. 2y cubed times x squared is just going to be 2. We usually do this alphabetically, so x squared y cubed. And then negative 2y to the fourth, because you have y cubed times a y to the first. All right. Technically speaking, we should put this, I guess, in standard form, meaning, and there are a few rules that change when you're dealing with multiple exponents. And so the answer I would actually give would be I would pick the x variable because it comes first, and I would do the larger x's first. On a problem like this, if you have it in the wrong order, I don't care that much. Just let's make sure we get the multiplication right. So the biggest x involved would be the x cubed. The next biggest x would be plus 2x squared y cubed. The next biggest x is the negative xy, followed by the one that has no x's, negative 2y to the fourth. And again, if you put it in a different order, I'm not too worried about it. Okay, and then we get to one that is not a binomial times a binomial. And so what I'm hoping you realize is that the plan is going to stay the same. We've got a trinomial times a trinomial. So I'm going to make a bigger box here, because I just need more room to organize. This time, I'm going to have an x and a y and a 5. So I'm going to break this part as x, I'm going to break that as y, and the final part as 5. And then I have a 2x, I have a negative 4y, and I have a negative 2. So I'm going to break it in to the following. So I'm going to actually have to find the area of 9 little boxes. 2x times x, 2x squared. 2x times y, 2xy. 2x times 5, 10x. Now I'll find the area of the middle row here. So negative 4 alphabetically, xy. Negative 4y squared. And negative 20y. Negative 2x, negative 2y, negative 10. Okay, now I'm going to put all these together. So which ones are in common? Looking real close here, I'm going to mark a few. I see x's and x's. I see y's and y's. I see an xy and an xy, and everything else is on its own. So the order isn't going to matter as much on this one. But again, technically speaking, we should do the biggest x's first. So I'm going to do 2x squared. Maybe I'll cross it off as I go. And let's not analyze it too much. Let's just go. I'll do the pink ones. So that would be negative 2 xy's. Negative 4 of them plus 2 of them. They're the same. So we just do the negative 4 plus 2. Took care of those. Let's do our x's. Negative 2x and 10x would be 8x. And then let's do, doesn't really matter. We'll do the negative 4y squared. We'll do the negative 22y, and then the minus 10. So real quick here, let me mark the pieces. So here's the y piece. The pink piece was the xy's, and the x piece was here. Okay. So really all this area model is just a way to organize and make sure you do all the individual multiplications you need to do. As we get past this intro, we will do this without the area, but for now we're going to stick with this area. All right. Next up, just kind of this little story problem here, this little thinking problem. So how would you find the area of this orange part? Find the area of the shaded portion. So what I visualize here is if I was going to make this out of like orange construction paper, I would cut out the big orange square, so I know the big amount, and then I'm going to cut out or take away the area of the little part. So I see this as a subtraction. So I'm going to say the whole area minus the small area. And so I need to find the area of the whole thing. So I need to do 2x plus 5 times 3x plus 1. Then I need to subtract the small area, which is length times width. So minus x times x plus 2. So I got to do the multiplication, 2x plus 5 times 3x plus 2. And then I'm going to subtract, and the subtract is going to be key here, the rest of it. So let's figure out the individual pieces. So let me just do it this way. 2x and a 5, 3x and a 1. So this is 6x squared, 15x, 2x, and 5. And then if you want to stick with the area model, which you don't have to because we know what to do with this one, but technically we have something like you have x and 2. So we do x times x is x squared, and x times 2 is 2x. So notice this area model just helps us organize our distributive property, which is going to be a hint for how we're going to do this in the future. All we did was a bunch of distributive properties here. All right, so let's find the area of each one. So this is going to be 6x squared plus 17x plus 5. And here's where you're going to make your most critical error if you otherwise have done everything correct. We're subtracting, but we're not just subtracting x squared and adding 2x, right? We're not doing that. What are we doing? We're subtracting all of that, right? We're taking away the whole area. And if you don't put parentheses when you're subtracting something that has multiple parts, you'll end up just subtracting the first part and not the second part. We have to put it in parentheses when we're subtracting. Have to. No other way around it. So then how are we going to do this? So this goes back to our adding and subtracting of polynomials. So I would like you to rewrite the problem and distribute the negative. Negative x squared, negative 2x. You could have, not to make things more complicated, but you could have instead, when you did this area from the beginning, you could have distributed the negative x and done negative x times x squared. That would have given us negative x squared, and negative x times 2x, negative 2x. So two ways to approach it. Either treat it as an x times, but then you're still subtracting, or treat it as a negative x times, and then you don't have to worry about subtracting. Either way, we end in the same place. The answer to this question, combined like terms, we would have 5x squared, we would have 15x, and we would have plus 5. So if we knew what the x's were, we'd be able to find the area of the orange part. But for now, we let it stand as a expression. All right, this next one. You could do this a couple of different ways. I'm visualizing it. Let me show you how I see this. And I don't really know what's the best way, but we could do a couple of things. So let's talk about it. We could make the orange rectangle whole, in which case we'd have 3x plus 10 across the top. And then how long would the whole side piece be? What I'm trying to indicate to you is we're going to call this x plus 1, and then everything else, right, is 20. So the whole thing would be something like x plus 1 plus 20, or x plus 21. So we could find the area of the whole thing, and then, like we did in the last one, take away the parts we don't want. So then I would subtract out this little white square, and I would subtract out this bigger white square. So that's what we would call as a subtractive model. But it may be easier to do this one as an additive model. And so let's think about it as an additive model. And you could cut this up in any way that you want. But much like I did with my area model up above and all those problems, we can divide this into rectangles we can calculate. So I'm seeing this as the easiest one right here. I'm going to cut the rectangle right there. So then I have part A, which we know the length, 3x plus 10, and we know the height, x plus 1. Part B, including the white area of x of this little one right here, would be 20 and x plus 2. And then I would take away from that the C value. So I see this as take all of A plus all of B, which includes too much. It includes this part I don't want. So I'm going to turn around and take away the C. So what is A? A is going to be 3x plus 10, the length, times the height or the width, x plus 1. So that's the area of A. Plus B, we have x plus 2 across the bottom here. And the height is 20. I'm going to put the 20 in front. I like my distributive properties to have the individual monomial in front. So 20 times x plus 2 minus the square there, the x times x, that is C. So then I just need to figure out the answer to these three questions and then subtract them and add them. So here I'm going to use my area model, 3x and 10, x and 1, 3x squared, 10x, 3x, and 10. I already know what this is, just the distributive property. So plus, this would just be 20x plus 40. And then x times x is just x squared. So the only thing left to do is kind of clean this up, figure out what the first one is. So we get 3x squared plus 13x plus 10 plus the other part. Subtract away the stuff we don't want. So I see the area as 2x squared, 13x and 20x would be 33x, and 10 plus 40 is 50. So if I knew what the x value was referenced in this question, like if I told you, oh, find the area if x is 2, we don't have to now go from scratch. We can just go down to this expression we wrote and plug in x is 2, which would be super handy if you were going to do it like 5 times. Like what's the area when x is 2? What is it when it's 3? What is it when it's 4? Etc. If you didn't make this expression, you'd be stuck having to do all of that over and over and over again. And so what we have created is an easier way to find the total area. All right, that is it for today, is our intro to multiplying binomials together, and we will expand upon this in the next lesson.